What a week, huh?
Beth, it's Wednesday.
Oh, right.
We have pretty pictures. Is that enough?
And rockets. Pretty pictures and rockets.
Yep, all of this now, right here on the Daily Space. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put pretty science in your brain. There are days when all of us just need to look at pretty things, and astronomy is here to say, we got you. In this first segment, we're going to just take in some pretty sights and leave the science behind, sort of. For instance, consider kilonova GW 170817. Back in 2017, the light and gravitational waves from two merging neutron stars reached our world. But not everything arrived at exactly the same time. On August 17, gravitational waves were detected by LIGO and Virgo, and high energy gamma ray light was detected by Fermi. Researchers quickly turned pretty much any telescope they thought might be useful at this event. And on the list of telescopes was the Chandra X ray Observatory. Initially, this telescope saw nothing, but undeterred, Chandra kept returning to that spot in the sky, and on August 26, 9 days later, X ray emission was detected. And then things got weird. According to a release from Chandra, this non detection of X rays, quickly followed by a detection, provides evidence for a narrow jet of high energy particles produced by the neutron star merger. The jet is off axis, that is, not pointed directly toward Earth. Researchers think that Chandra originally viewed the narrow jet from its side and therefore saw no X rays immediately after the gravitational waves were detected. However, as time passed, the material in the jet slowed down and widened as it slammed into the surrounding material. This caused the cone of the jet to begin to expand more into Chandra's direct line of sight, and X ray emission was detected. Since early in 2018, the X ray emission caused by the jet had steadily been getting fainter as the jet further slowed down and expanded. Hajela and her team then noticed that from March 2020 until the end of 2020, the decline stopped and the X ray emission was approximately constant in brightness. That last step, the X ray emission appearing constant in brightness, that is weird and seems to indicate there is something more than just a jet generating this light. Option one, which has been turned into some truly amazing artwork that we'll link to on our website, dailyspace.org. Option one has a shock wave from the merger hitting surrounding material and superheating it so that it glows in X rays. This kind of afterglow is something we see with other kinds of gamma ray bursts and would be the first time we've seen an afterglow from a neutron star merger. Alternatively, we could be seeing light from material falling into the black hole that formed when those neutron stars merged. This would be the final photon screams of material about to fall into the event horizon. Further observation should be able to sort out which of these options matches reality. For now, these results are published in the Astrophysical Journal Letters in a paper led by Aprajita Hajala. And while the X-ray observations themselves are just a blob, go check out the artist's rendering. It is truly amazing.
And from a prettily illustrated system, we now turn to a beautifully imaged system. Galaxy NGC 1566 is a grand design spiral galaxy that we get to see face on in the sky. Recently observed with the Cerro Tolola Inter-American Observatory, researchers find in the details of this system the remnants of a 2010 supernova, blue shining star formation regions, and a shining disk around the actively feeding black hole. This galaxy was imaged as part of the Dark Energy Survey, which has been mapping large areas of the sky in ways that allow distant galaxies to be seen with never before imaged details. While the survey imaging ended in 2019, the research discoveries are just beginning. This particular system is unlikely to bring us any deep insights on dark energy, but since surveys image everything in a region of the sky, they acquire data useful for, well, let's call it off label usage, and that's what this is. NGC 1566 is the dominant galaxy in a nearby galaxy group called the Dorado Group. Its role in that group and its great alignment in the sky make it a fabulous system to use to study what environmental conditions may lead to galaxies looking and acting in different ways, including looking at how its neighbors support NGC 1566's grand spiral shape.
With galaxies, the question of nature versus nurture comes down heavily on the side of nurture. From NGC 1566's spiral structure to the gnarly triangular starbursts of ARP 143, interactions between systems shape galaxy after galaxy. It turns out that if two galaxies of just the right masses line up in just the right ways, you get a grand design spiral. But if things are just wrong, you get what looks like a lightning bug splatting in its death on the sky. The ARP 143 system consists of two galaxies. One is a blob of ruddy light that is distorted through its interactions with its neighbor. This is NGC 2444. That red color indicates it is dominated by older stars, at least for now. The other system, consecutively cataloged as NGC 2445, consists of a round core of light surrounded by a massive triangle of star formation. Triangles aren't a typical shape for galaxies, and in this case, the shape is created by the pull of the red round NGC 2444. It's thought these systems pass through one another, triggering the star formation and allowing NGC 2444 to pull material with it as it escapes. Newly released images from the Hubble Space Telescope are allowing researchers to tease out new details in this collision. Specifically, Hubble's image reveals dark webs of gas and dust blocking light from the star forming NGC 2445's core. These structures were formed by outbursts of material and are backlit by stars that have formed in just the past million or so years. This kind of beautiful destruction is just one step in a multi-billion year merger process that will eventually bring these two systems together to form one larger galaxy, one likely devoid of new stars. We're witnessing one final gasp of star birth before systems settle into a long red future. From distant galaxies in all their beauty, let's now imagine sunsets from other worlds we know exist in our own galaxy. Stay tuned.
This next pair of stories comes with pretty pictures as well, but instead of images taken by spacecraft, we have artist illustrations. Exoplanets, it turns out, are difficult to take detailed pictures of at this point in time. At best, you get a blocked out star and a tiny bright dot next to it. Although our telescopes are improving decade by decade, we still have to imagine what these distant worlds might look like. That's not to say that we cannot detect exoplanets from the ground. While Kepler and TESS use the transit method of finding exoplanets, where they look for dips in the light of a star as a planet passes between the star and the space telescope, ground based observations can also find and confirm worlds in other star systems. To do this, they use the radial velocity method, where they measure changes in the velocity of a star as an orbiting planet gravitationally tugs on it. And astronomers using the 193 centimeter telescope at the Observatoire de Haute-Provence in France were able to detect the known exoplanet Kepler 16b. This particular world fascinated everyone when it was discovered 10 years ago because it was the first circumbinary exoplanet discovered, proving that a world like Tatooine in Star Wars could and in fact does exist. The team chose this target to prove that their telescope could be used to find exoplanets, as Dr. Isabelle Boise explains. Our discovery shows how ground based telescopes remain entirely relevant to modern exoplanet research and can be used for exciting new projects. Having shown we can detect Kepler 16b, we will now analyze data taken on many other binary star systems and search for new circumbinary planets. The results of these observations were published in the monthly notices of the Royal Astronomical Society. Good luck to the team in France. May you find many more circumbinary planetary systems.
Of course, once you find a planet, you want to learn everything you can about it. And of late, that task has expanded beyond calculating mass and density and turned to understanding distant atmospheres. We've talked before about how, while waiting for a certain new telescope to launch and begin actual scientific data collection, researchers have used existing telescopes to peer into exoplanetary clouds. And they've done some incredible work with what they had, including getting the most detailed look at the night side of a tidally locked hot Jupiter. The planet is WASP 121b. It was discovered in 2015, is about 855 light years away from our solar system, and has a mass about 20% greater than Jupiter's mass. It's also nearly twice as big as Jupiter. Additionally, it's tidally locked to its star. That means the same side always faces the star, and it whips around in a blistering 30-hour orbit. But because we can still get some separation between the planet and the star as it orbits, we can get a glimpse of the day side before it passes behind. Now, in a new paper published in Nature Astronomy, the researchers published the merged data collected from both hemispheres of WASP 121b, an analysis of the atmosphere as a global system. Co-author David Singh briefly explains. To probe the entire surface of WASP 121b, we took spectra with Hubble during 2 complete planet revolutions. What they found was seriously interesting. WASP 121b has an upper atmosphere that can reach temperatures up to 3,000 degrees Celsius on the day side, which makes the water molecules glow and even break down. On the night side, temps drop to 1,500 degrees Celsius, and this gives rise to incredibly strong winds that move those glowing, broken water molecules to the cooler side of the planet. Of course, in cooling the atmosphere, the hydrogen and oxygen can recombine, become water vapor again, and get swept back to the hotter day side. Lather, rinse, and repeat. But since the water vapor isn't allowed to form clouds long enough or big enough to rain, what else is in the atmosphere? Metals. Specifically iron, magnesium, chromium, and vanadium. And those metals can condense into clouds on the night side and possibly cause a rain of liquid gems like rubies and sapphires. No, really, it's raining gems. Hallelujah. Next up, the team hopes to get some time on that not yet collecting science data telescope that I will not name. And now, we're going to switch gears again and go to Eric Mattis with rocket launches.
Before we can get to this week in rocket history, we have to talk about a rocket launch from yesterday. On March 1st at 21:38 UTC, a United Launch Alliance Atlas V 541 launched the GOES-T spacecraft into high perigee geostationary transfer orbit from Zlik 41 at Cape Canaveral Space Force Station. Let's watch the launch.
5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Gerald, let's listen in as we listen to United Launch Alliance Rob
This look good.
who's the flight mission commentator.
View has gone to closed loop control.
The GOES satellites are operated in geostationary orbit by the National Oceanographic and Atmospheric Administration, or NOAA. NOAA has been operating weather satellites in geostationary orbit since 1974's Synchronous Meteorological Satellite 1. Geostationary orbit allows satellites to image the entire disk of the planet at once, compared to the tens of kilometer-wide strip of satellites in low Earth orbits. This allows forecasting of weather patterns around the globe. GOES-T is a part of the GOES-R series of satellites and will replace the previous satellite, GOES-S, also known as GOES-17. GOES-S had a problem with its primary instrument, the Advanced Baseline Imager, and needed to be replaced as soon as possible. The ABI on GOES-T and the upcoming GOES-U was fixed before launch. In NOAA tradition, the satellite will not be given a number designation until it's in orbit and tested. Once GOES-T enters service, it will be known as GOES-18. And now we go to another remote sensing satellite in This Week in Rocket History. Stay tuned. This week in rocket history, one of the biggest remote sensing satellites ever launched, Envisat. Envisat was an Earth-observing remote sensing satellite built and operated by ESA. Launched in 2002, it was operational until 2012, when it suffered an anomaly that resulted in it going into safe mode that it never recovered from. This is its story. The history of the Envisat satellite starts back in 1990 with a related project called the Polar Platform, an uncrewed remote sensing satellite designed to be visited by ESA's planned Hermes spaceplane. The goal of Hermes was to give ESA a crewed spaceflight capability. In addition to the goal of visiting the Polar Platform, it was also planned to visit a crewed ESA space station called Columbus and NASA's Space Station Freedom, which later became the ISS. Because of budget overruns and the availability of inexpensive Russian space hardware after the fall of the Soviet Union, the Hermes program, including all of the various missions, was canceled. However, that wasn't the end for some components of the Hermes program. The Columbus station became the Columbus module on the ISS. Instruments from the Polar Platform became two standalone satellites called NVSat and METOPSAT, short for Meteorological Operations Satellite. The development of Envisat's payload instruments started in 1993, following the cancellation of the Polar Platform. The design of the satellite bus was optimized to maximize the payload mounting area, while still being able to fit in the fairing of an Ariane 5. A total of 10 instruments were selected, which accounted for over 2 metric tons of the 8 metric ton spacecraft, which was 10 meters tall, or about as long as a telephone pole, making it the largest European satellite launched at the time. The instruments consisted of 2 radars, 2 radiometers, 3 spectrometers, and an interferometer. In addition to these, there were 2 instruments designed to make it easier to track the satellite in orbit: the DORIS, or Doppler orbitography and radio positioning integrated by satellite, and a laser retroreflector. As it turned out, these 2 would end up being very useful. To save money, Envisat used the same service module, or the part that provides power and propulsion, as another remote sensing satellite, Spot 4. Using a completely independent service module reduced risk in development because the payload module and the service module could be developed and integrated separately and only combined shortly before launch. Envisat was launched on its planned 5-year mission on March 1, 2002, aboard the 11th Ariane 5 rocket. The launch was successful, which was the relief for everyone because over the course of the previous 10 Ariane 5 launches, there had been 1 complete failure and 2 partial failures, including the launch before Envisat. Despite these initial growing pains, Ariane 5 has gone on to become one of the most reliable rockets in the world, which serves as a reminder that space is hard. Immediately after launch, the satellite autonomously activated its solar panel release mechanism and pointed towards Earth. It raised its orbit the next day and unfolded its big radar on the 4th day after launch. The payloads were powered up through the rest of March and early April 2002. Commissioning of the instruments took place between September and December 2002, with the start of routine operations occurring January 1st, 2003. The satellite completed its planned mission in 2009 and was extended through 2013. However, on April 8, 2012, control of the satellite was lost for no immediately obvious reason. On April 15th, 2012, the high-resolution optical imaging satellite Pleiades took a picture of Envisat to help ground controllers diagnose an external cause to the disruption. But even with this, controllers were unable to determine the cause. One possible reason may have been a short circuit that put the satellite in safe mode, but we'll probably never know for certain. Envisat's mission officially ended on May 9th, 2012. It will take at least 150 years for the spacecraft to decay from a nearly 800-kilometer orbit. A mission called Deorbit was planned by ESA to deorbit Envisat, but it was cancelled in 2018. Though it ended, Envisat more than doubled its expected lifespan and delivered 10 terabytes of data on Earth's land, atmosphere, oceans, and ice caps for disaster and climate change monitoring. It was replaced by the Centennial series of satellites. And now for some statistics. The number of toilets in space is still 8. 4 on the ISS, 1 on the Soyuz, 1 on the Crew Dragon, 1 on Shenzhou 13, and 1 on Tianhe. We keep track of orbital launches by launch site, also called spaceport. Here's that breakdown. USA 13, China 4, Kazakhstan 2, India 1, New Zealand 1, Russia 1. From those 22 launches, a total of 426 spacecraft put into orbit. Your random space fact for this week is that NASA sent 2 bullfrogs into space to obtain the first direct measurements of the otoliths, or inner ears, response during weightlessness. Called the Orbiting Frog Otolith, it was launched on a Scout B rocket from Wallops Island on September 11, 1970. Recovery of the frogs was not planned, and they died in orbit 7 days into the mission when the spacecraft's battery failed. This has been the Daily Space.
And I apologize for that space fact, but the more you know. You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.